Okay, so if you have installed Anaconda, it's okay. But even though without Anaconda also you can execute the programs. Okay. So what is the experiment? So second experiment is extract the data from database using Python. So now what you're doing, you'll be having much data. So there are many data sets available. So what you want, if you want to execute any particular system, you want some data. Okay. So whatever the data which you want, that you can extract. And you can implement in your system with some algorithm. Okay. So now I'll tell you how to extract the data. So second experiment is extract the data from database using Python. Okay. So now I'll be extracting the data and executing Colab. Okay. So many of you are not having Anaconda in your systems. You can just execute the programs in Colab also. Okay. So Colab is nothing but it is a cloud which allows anybody to write code with a simple system. Okay. So now, can you see the screen and can you hear me?
Yes, ma'am.
Okay. Just type Colab, enter, and you will get Google Colab. Just click on that. Okay. So you will get one window. It consists of examples, recent, Google Drive, GitHub, upload, all these things. Okay. If you see Google Drive and GitHub, these two, Google Drive is your drive. Okay. So GitHub is a data where data is present, or you can upload the data, or you can extract the data. Okay. You can use this particular database. Now, you can see one new notebook on the bottom. Just click on that. You will get one window. It is related to Colab. There you can execute the programs. Okay. So this is your Colab environment. Now, what is our program? Extract the data from database using Python. Okay. So what you have to do, you have to extract the data from database. So what you do, just sample data file download. So you want to download. Here you can examples, different sample. So here you can see sample data, anything, any data file you can on that. So guys, so here you can pick anyone. Data blending file, data blending file, data joins, sample data, super. Okay, I have downloaded one file. What you have to do, save this Excel file as CSV. Save desktop, okay. You save it as save. Okay. Now you see file has been saved. One second, it has been wrongly saved. Desktop blending. Yes. Yes. It has been saved on the file. Okay. So what you do? File and I can extract. Go to your drive. Okay. Save the download in a particular case. Now upload this file in your drive. Okay. New file upload. Blending. What you have to do is just Now you can see the file in your drive. Okay. Now what you can do is the file you can extract and you can execute and you can use this file to your program. So from where you are extracting the file, Google, Colab, mount your drive. That means you have to give the connection in between these two. Word is there, that is connect command. So what you do is if you connect it to Colab GPU. Whatever the program which you do, okay. Now Colab import enter, right, enter drive dot the okay. You can see what to do here is just the particular or uploaded to the drive, take mail, click on the link which is there, just copy that and paste, enter. To mount Colab with the drive. Okay, one message has been given to us. Now what you do is next click on code. Click on code. Okay. Import pandas.
Excuse me, ma'am.
Yes.
Your screen froze, ma'am. I mean, last thing we see is your Gmail. You're logging into your Gmail account.
Sandeep,
Yes, ma'am.
yeah. Any sir, you are asking something.
No, ma'am, your screen froze. It just started that.
Shall I repeat it again?
Ask them, ma'am. I've already installed the account.
Huh?
Yes, ma'am. Try repeating.
Okay, from starting, I'll just close this. Colab. Okay, just click on Google.
Ma'am, it froze again.
Yeah.
It froze again, ma'am. We can only see the Jupyter notebook, the cells.
What do you want? You have this. Is it visible now?
No, ma'am. We can only see the cells from Jupyter notebook.
Guys, respond something.
No, ma'am. I guess your screen froze again.
Now it is not visible to you.
Now it's visible, ma'am. Now it's the
Yeah.
meet layout.
Okay. Yeah. So first, what you have to do, upload a data file to your drive. Okay. So for uploading, what you have to do, new file upload. Okay. So where desktop, on desktop. So what you have to do, select that particular file. Go to desktop, select that particular file, upload that file into your drive. Okay. Now you have to mount the drive with Colab. So from Google dot Colab import drive. Okay. Enter drive MOUNT mount drive. Yeah. Mounting your drive with Colab. Okay. Now just run this. Click on the icon. Okay. That link. Class to link the file has been stored. Now click on that name in my and now you'll get one link. Just copy this link. Been copied, paste in the box.
Ma'am, it froze again.
Okay. Now what you do is you have to extract the data.
Ma'am,
As PDF. Yes.
screen has frozen again, ma'am.
Now
Yes, ma'am. Now it's visible, but when
Sandeep?
you're yes, ma'am. Now it's visible, but when you're uploading the data file, it's been frozen.
The steps are clear or not?
Uh, yes, ma'am. I've understood, but I don't know about the rest.
About a rasa. That's what I'm saying. Today the net is very slow. Okay. Just what you do is, once again I'll repeat this. Just what you do is how the data is uploading. You just understand and you can explain to your friends if they want. Okay.
Okay,
Sandeep,
ma'am.
is this clear?
Yes, ma'am. They could watch
Okay.
any YouTube tutorial or something.
Okay. Import pandas as PD. So now pandas is used. This is a library. Okay. So this is one particular method which is used for reading or processing the data sets. Okay. Enter df. Df is nothing but data frame. That is equal to PD is panda dot read underscore CSV, the file which we want to read. From there, just give the link drive slash my drive slash. What is the file name which I have given? Ready. Okay. CSV. Okay. Now enter print df data frame. Just run that. Okay. So in this way you can extract the data. Whatever the data which has been uploaded or downloaded, that data I can extract here, and I can just items to this. So in this way, you're going to extract data from different databases. Okay. Now click on len df. And the df. So you run this level, what happened? The data frame size will be given to us. Okay, so what is the data frame size here? How many rows which are there in the data set? From 0 to 18, the rows are 19. So it is displayed as 19. So in this way, you can use any particular command to your data set. So now I don't know if you have understood it or not. So in this way, you will be extracting the data. Is clear, guys? So if you have not
No, ma'am. Yes, ma'am. Yes, ma'am. Now we can hear.
Yeah, that only I'm saying. From morning onwards, there is much net issue. Okay, so I don't know whether you have understood the second experiment or not. Just once again, I'll repeat it. Take a new notebook. So first, what you have to do is any file, whatever the file you want, just download that file. Okay, download that file and upload to your drive. Go to drive, new, click on new. File upload option is there. Click on file option, file upload. So if you are downloaded the file, that will be in downloads. Okay, you can see sample copy is there. I'll upload that. Click on sample, click on open. So just refresh your drive. So the file has been uploaded to your drive. Now what you do is you want to extract this file. Go to Colab. Okay. Before extracting, you have to mount the drive here. So for that, the statement is from google.colab import drive. So you are mounting your drive with Colab. Run this. Click run button. You will get one link. Just click on that link. So just click on the mail ID where the file has been stored. Click on hello. Okay. Now copy that link. Copy. Okay. Now what you do is just copy that link, paste it here, click on enter. What will happen? It will be linked with your drive. Okay, the Colab drive will be with your drive. Now you want to extract the data. Import. Import pandas as PD. So pandas, as I have told you, it will be reading the processing the data sets. This is a particular method and it is one of the library which is used in Python. Okay. So now run this cell. So in this way the data is extracted. Okay. So if you want to check what is your data size, as your data size is very large, so what you have to do here is you want to check your data size, data set size. So length of df is nothing but data frame. Just click on that. Okay, so in this way you will be getting the size of your data set. So now take one more. I want to extract one more data set, one more file. So that is sample. It is also in my drive. Now what I am doing here is just click on that. So in this way you will get your data set. Okay. So now if you see the data set is very large. So just click on this. So it will tell us what is your data set size, that is 500. So in your data set, total 500 rows are there. Okay, so in this way you can extract and you can use this particular data set to your system or in your program. Okay, so wherever necessary, whatever data set necessary. So in this way you will be extracting the data from database. Is this clear now? Now it is visible. Guys, don't sleep. Just respond something, whether you have understood or not. Guys, respond something. So what you do is in your home, just try download one file, extract that file in Python or Colab. Okay. So till now we have extracted the file from drive by using Colab. So in the same way you can use this in Python also. Okay, and I'll show you. Open Jupyter Notebook if you have downloaded Anaconda in your systems. Okay. Now open new Jupyter Notebook. So I have sent you all the programs. Program 2. So this is your program 2. Now what you do is run this program. So just you can run a sample copy. In this we are having 2-3 Excel sheets data files which can be extracted. So here only this is one file that is related to restaurant. Okay, that file you are extracting it. Just run that. So it is saying invalid syntax. Why? Because I am not having MySQL in my system. All of you, if you want to extract the data from the database, so what you have to do, you should have MySQL. Why? Because we are connecting to MySQL. In Colab, we have extracted the data from drive. Okay, so here you can see MySQL connect. So this is your connector which will connect to your database. From there the data file will be extracted. Okay, so what is your file here? Your file is social network. social network ads. Okay, so this you have to extract. So this can be done by using MySQL. Okay, so this, if you are having MySQL in your systems, you can execute this file in your systems if you have downloaded or you have installed Anaconda in your system. Okay, so this is by using Jupyter Notebook. If you want to execute or if you want to extract the data, you'll be doing by using MySQL. You'll be extracting the data by MySQL by connecting the file with your drive with MySQL. Okay, so for wherever the data, wherever the file it has been stored, that should be connected. Okay, you have to give the connection in between these two. So this is about your second experiment, that is extract the data from database using Python. I'll tell one topic and I'll close. Okay. So in the morning we are discussing about candidate eliminate algorithm. So this is very important algorithm. With that you can know what is the set of hypotheses you'll be getting for positive examples and for negative examples. Okay. So before going to that, just I want to tell you. So in your data set, it consists of positive and negative data. Okay. So here I'll show you. So here you can see high risk, low risk, medium risk. So for giving home loan, yes, no. So based upon the data, what is the risk, whether you can give the loan to the customer or not. Okay, so that we can say here you are having the different outcomes, that is high risk, low risk and medium risk. So this is your observed data, observed output. So now what you have to do, you have to predict it whether it is correct or not by using one algorithm. Okay, so here you are having positive and negative, both outputs. So in candidate elimination algorithm, the main important role plays over here is version space. So what is version space? Version space is intermediate of both specific and general hypothesis. It returns set of all possible hypotheses based upon the training data set. So as I have told you, you will be having all the hypotheses. It is a set of all the hypotheses. Adi negative example toti gaani, adi positive example toti gaani. Annititoti group ayi unde danni set ni version space antaru. Okay. So from that version space, what we have to do here is whichever hypothesis is consistent, that we have to retain. Otherwise, inconsistent hypothesis should be removed. So this can be done by using candidate elimination algorithm. Previously, we have did by using less than algorithm. In less than algorithm, what has happened? Either specific boundary toti gaani, either generic boundary toti gaani. In any one way we have used, and we will be finding the main important boundary, main important hypothesis. Okay. So candidate elimination algorithm uses version spaces. It has both specific and general hypothesis. It considers both positive and negative examples. And here for positive example, we tend to generalize the specific examples. We move from top to bottom. That is nothing but specific to general. But in case of negative example, what we do, we move from bottom to top. That is nothing but we tend to make general hypothesis more specific. Okay, general and the specific morning explains. What is general? General is nothing but either this or that. If you take sky or temperature, temperature is low, medium, high. So in this way, we are specifying some value over there. But in case of specific, there is null value or any value is specified. That's all. Okay. So this is specific. So this is the difference between general and specific. And in our data sets, both will be there. So what we have to do, we have to consider both and we have to find the hypothesis, main important hypothesis, the set of hypotheses that we have to find. And we have to consider both the things, that is specific boundary and generic boundary. Both we have to consider and we have to find out the main set of hypotheses which we will get. Okay, so this can be done by using candidate elimination algorithm. One second, I'll tell you with one example. Consider this example. Okay. So here in this example, in this data set, in this data, in this table, you are having 4 rows, that is called as 4 examples, or you can call it as 4 records. Okay, and you are having 4 and 5 attributes. One is citation, second one is size, third one is in library, fourth one is price, and the fifth one is edition. So these are the 5 attributes are there, and by is called as target concept, target function. That is nothing but observed data. Based upon this data, it has been observed. So if you take the first row, citation is small, citation is something, size is small, in library is no, price is affordable, edition is 1. You can buy that. You cannot buy that. That is nothing but no. Okay. So based upon the training example data, you have observed the output here. Now what you have to do, whatever the observed data is there, that is correct or not, that you have to find. Okay. So this can be done by using candidate elimination algorithm. So here the first step is starting when what you have to do, S0 you will be specifying with 5 symbols. Sorry, it is 0 here. You have to specify with 5 symbol every time. S0, that is initially you will be specifying. S is nothing but specific boundary. The boundary should be specified with 5 symbol. This is initially. In the same way, generic boundary also will be specified with question mark. G0 on the bottom you can see G0 is specified with all the question marks. So this is your first step. Specific boundary is specified with 5 symbol. Generic boundary is specified with question mark. Now take the first example. What is your first example? First row. Example at the first row. Take the first row. When first example or instance is negative. So here in this table you can see first example, it consists of negative, that is no. Okay. So what we have to do here is take the first row, okay, as it is negative. Now what you have to do, whether the particular hypothesis, initial hypothesis is consistent or not, that we have to check. Okay, if it is consistent, then we have to retain the boundaries, generic boundary and the specific boundary as it is, otherwise we have to change that. Okay, so that I will tell you how. So here as it is negative, so what we have to do here is, it does not match with the first row. Negative values ఇక్కడ తీసుకుంటాం మనము, నెగిటివ్ వాల్యూ స్పెసిఫిక్ దానికి తీసుకుంటాము ఇక్కడ నేను. So here you can see, specific boundary version space is the set of its maximally specific members consistent with the. Here summarizes the positive examples. Anything more specific will fail to cover a positive training experience. So what you have to do is summarize the negative examples. Anything more general will cover a negative training example. So you will go with general boundary here. Okay, so as your first row is negative, so what you do, you start with specific one. Okay, so what it is saying, it is consistent. So what we are doing here, the first row does not match with null, as it is not matching with null. So what we are doing, null it is saying as negative, and whatever the expected one it is there, it is also negative, that is no. So what it is happening, these two are same. Whatever the specific boundary is there and whatever the first row which is there, that is giving us same, it is matching here. So what we are doing here, we are keeping the specific boundary as it is. So S1, it is written as all with 5. Okay, now what you have to do, you have to check the first instance with the generic boundary also. Okay, so once again I repeat it. Initially, every time the starting boundary will be 5 for specific boundary. For general boundary, it will be question mark. Now what you have to do, take the first row. As the first row it consists of negative value, so you have to start with specific. Okay. Okay, so as whatever the initial boundary which we have specified, whatever the initial hypothesis which we have specified for specific, it is saying as negative, and this is also negative. So both are matching. So what we have to do, we have to retain it. That is nothing but both are same. So it is consistent. Whatever the hypothesis specific boundary is there, that is consistent. So we will retain it. Okay. So that is nothing but S1 5 5 5 5. So 0 rather than 5 simple. Now again you have to check whether the first row is consistent with the generic boundary or not. That we have to see. What is your initially generic boundary? Question mark, all question marks. Now compare all this question mark with the first row. Okay, so first time the question mark, the hypothesis contains all question mark, and all question marks match with the first row. ఎందుకంటే question mark కి మనం ఏదైనా రాయొచ్చు. We can write any value for question mark, any general value for question mark. So what is happening? G0 is giving us, is classified as positive, and here in first row we are having, it is expected as negative. So what we have to do, hence hypothesis is inconsistent. Inconsistent kabatti, now you have to change the generic boundary. Okay, if it is not inconsistent, if it is inconsistent, we have to change the hypothesis. So we have to change the generic boundary here. Okay, hence hypothesis is inconsistent with respect to the first row. Okay, now change the generic hypothesis by replacing all with the values with the first row values with question marks. Okay, so now what will happen? You will get in this way. So what are all these hypotheses? That is nothing but first question mark. Take the first question mark in G0, compare with the first row. So you can write question mark. Here it is in first row, it is having sum. So what you have to do? You have to write opposite to that. So what is the opposite value which is there in that first column? Many. So you will write with many. Many comma all question marks for first value. The same way for second question, big. What is the value which you are having in your first row? Small. Small only. Small badal mere em rayali, big rayali, opposite ga rayali. So big comma all question marks. Next, one more value is also there. We will be getting one more hypothesis here. So for second question mark, we will get two hypotheses. One is big and one is medium. Take the third question mark in G0. Okay. So third question mark is no. So there is no another value here. So it will not be changed and we will not get any hypothesis for this. Take the fourth question mark in G0. Compare with the price. Here it is affordable. First row have affordable only. Expensive and royal. Okay. In the same way, take the fifth question mark. Compare with the value of first row. That is 1. Now what you have to write? You have to write about that is many. And you will have few also. So for fifth question mark also, you will get two hypotheses. One with many and one more with few. So now generic boundary has been changed to G1 with 1, 2, 3, 4, 5, 6 hypotheses. Okay. In this way, you have to compare these boundaries with all the other instances, rows, examples, whatever you call. Okay, records. So now what you will do? Similarly, take the second row. Second row as it is positive until yes undi manaki ikkada. So we will go with generic boundary. Okay, and we will check all the hypotheses are consistent or not. These are all hypotheses consistent or not with the second example that we will check. If it is not, any one of the hypotheses is not consistent, that we will remove. Okay. Take the first hypothesis. First hypothesis what in G1 is many comma all the question marks. Now compare this first hypothesis with second row. Okay, hence it is positive classified. Many matches. Question will also match with all the other values. So first hypothesis is classified as yes, and here observed one is also yes. So what is happening? Both are matching. So we will keep this hypothesis as it is. Now take the second hypothesis. Question mark, comma, big, comma, question mark, question mark, question mark. Compare with the second row. So this will also match. So what we will do? We will retain it. Okay, consistent about it, we will keep it. In the same way, compare the third hypothesis. So here third hypothesis does not match. Question mark will match with many, but medium will not match with big. Second value, second row, second value to match with medium. So what will happen? We will remove this hypothesis. Now compare the fourth hypothesis. Again, question mark, experience, affordable, expensive, comma, question mark. Now compare this with second row. Okay. So what will happen? It is matching, so we will keep as it is. Now compare the fifth one. Fifth hypothesis in G1. So what is happening? It also matches, so we will keep as it is. Take the sixth hypothesis in G1. As it does not match, we will remove that hypothesis. After removing that, we will get G2 as 4 hypothesis. Now compare this with third one. So take the third example. As it is positive, compare with the generic only. Generic hypothesis toti compare cheyali. Okay. After comparing, you will get this one. So final hypothesis set is many, comma, question mark, comma, no, comma, question mark, comma, question mark for the generic one. Sorry, for the specific one. And for generic, you will be getting many, comma, question mark, comma, question mark, comma, question mark, comma, question mark. So this is your final hypothesis set you will get while applying candidate elimination algorithm. So if you try in your home, you can know. Just try for one example, then you can know what is happening. So how you will get hypothesis set. Yeah guys, any doubts regarding anything? Guys, respond something. Mishra?
Yes, ma'am.
So guys, is it clear? So just I repeat only one thing. So by applying the candidate elimination algorithm, initially specific boundary will be given as 5 with the set 5, and the generic boundary will be displayed with hypothesis question mark with the set question mark. Okay, any attributes unte anni question marks vastayi, anni 5 symbols vastayi. This is your initial step. What is your second step? Second step is nothing but you have to compare. You have to take the first row. Table of first row తీసుకొని అది నెగిటివ్ ఆ పాజిటివ్ ఆ. నెగిటివ్ అయితే స్పెసిఫిక్ తోటి కంపేర్ చేయాలి. స్పెసిఫిక్ తోటి కంపేర్ చేస్తే మీకు ఏమైంది, అది రెండు మ్యాచ్ అయ్యింది and it is giving us negative. So what we do, we retain that hypothesis as it is. Now compare the first row with generic. Okay, so after comparing that, you will get G1. Now what you do, compare, just take the second example. It is positive, so what you have to do, you have to compare with the generic one. So go with generic. Okay, so this is your G2 hypothesis you will get. Okay, in this way what you have to do is take the instances, see the output, whether it is positive or negative. If it is negative, compare with the specific boundary, otherwise compare with the positive. Initially you have to compare with the, if it is negative, initially you have to compare with the specific boundary, otherwise you have to compare, next you have to compare with the generic boundary. Okay, so this is candidate elimination algorithm. So here for each training example D, that is data set. If data set is positive, data is positive. Not, it is not capital D, it is small d. Small d is nothing but instance. Remove from G every hypothesis inconsistent with D. For each hypothesis S in S that is inconsistent with D. Remove S from S, add to all minimal generalization H of S such that H is consistent with D and some member of G is more general than H. This is the algorithm for candidate elimination. So tomorrow what you do is try for this. This is your data set. Try candidate elimination algorithm for this and tell me what is the hypothesis set which you will get. Tomorrow in class I ask each and every one. What is the hypothesis set which you will get to this particular data set by using candidate elimination algorithm. Is ఎవరికి కావాలి క్లాస్ ఉంది
అది రెడ్ క్లాస్